Delete a file. Empty the trash. In that instant, you did something with a fundamental, unavoidable physical cost. You warmed the universe. Just slightly, but not zero, and never zero, because the laws of physics attach a price to one specific act, and that act is forgetting. We treat information as weightless, a thought, a file, a memory, pure abstraction, floating free of the physical world. That intuition is wrong, and the proof is one of the most beautiful results in all of physics. Information is physical. It has a thermodynamic price, and that price quietly solved a paradox that haunted science for 150 years. Let me show you the cost of forgetting. In 1961, a physicist at IBM named Landauer asked a strange question. Does computing have to cost energy? And the answer he found was stranger. Most of computing, in principle, does not. But one operation does, unavoidably, and it's not the one you'd guess. It's not writing information. It's not doing a calculation. It's erasing. The act of taking a bit that could be a 1 or a 0 and forcing it to a known blank state, deleting it, has a minimum energy cost that no technology, no matter how perfect, can ever avoid. Here's the intuition. A bit that you don't know the value of has two possibilities, 1 or 0, two states. After you erase it to 0, it has one state, 0. You've squeezed two possibilities down to 1. You've reduced its uncertainty, its entropy. And the second law of thermodynamics is absolutely ruthless about this. Entropy can't just vanish. If you lower the entropy of the bit, that entropy has to reappear somewhere else, as heat dumped into the surroundings. Landauer put a number on it. Erasing one bit releases at least a specific tiny quantity of heat, a value set only by the temperature and a fundamental constant of nature. At room temperature, it's about 3 billion billionths of a joule, almost nothing. But it is not nothing, and that gap between almost nothing and nothing turns out to matter enormously, because it means forgetting is a physical event. To destroy information, the universe demands payment, in heat, every single time. Which sounds like an abstract curiosity, until you pointed at the ghost that had been breaking physics since 1867. In 1867, James Clerk Maxwell, one of the greatest physicists who ever lived, dreamed up a monster designed to break the second law of thermodynamics. We still call it Maxwell's demon. Picture a box of gas, split into two halves by a wall with a tiny trapdoor. Sitting at the door is a microscopic, intelligent demon. It watches the molecules. When a fast, hot molecule approaches from the right, it opens the door and lets it into the left side. When a slow, cold one approaches from the left, it lets it into the right. It does this over and over, sorting the molecules, hot on one side, cold on the other. Think about what that means. Starting from a lukewarm, uniform box, the demon has created a hot side and a cold side out of nothing, without spending any energy, just by being clever about a trapdoor. And a temperature difference is usable. You can run an engine off it. Forever. Free energy from a closed box, in flat violation of the second law of thermodynamics, the most reliable law in all of science. For over a century, this demon sat there, mocking physics. Nobody could quite say why it shouldn't work. The answer, when it finally came, was hiding in Landauer's cost of forgetting. Here is the resolution, and it's gorgeous. To sort the molecules, the demon has to look at each one and decide which way it's going. It has to measure, and then it has to remember, hold that information, at least for a moment, to work the door. And a demon with a finite brain has a finite memory. As it sorts thousands, millions of molecules, its memory fills up with records of what it saw. Eventually, to keep going, to complete a true cycle and start fresh, the demon has to erase its memory. It has to forget. And by Landauer's principle, erasing all that accumulated information costs energy, dissipated as heat. When you do the accounting carefully, The heat the demon must dump just to clear its memory is at least equal to the useful energy it extracted by sorting. Every jewel the demon seems to win by being clever, it has to pay back to forget what it learned. The book's balance. Exactly. The demon extracts no free energy after all, and the second law stands, rescued not by anything about the gas or the trapdoor, but by the physics of information itself. The demon's real fuel was never the molecules. It was memory. And memory, erased, costs exactly what it's worth. And this isn't just an elegant argument. In 2012, physicists actually did it. They built the simplest possible bit, a single microscopic particle trapped in a tiny double-welled landscape, sitting in one well or the other, a physical 1 or 0. Then they erased it, resetting it to a known state, and they carefully measured the heat that flowed out. It matched Landauer's prediction. The minimum cost of forgetting, calculated from pure theory in 1961, showed up on the lab bench 50 years later as real, measured heat. The price of erasing information is not a metaphor. It is a quantity you can put a thermometer on. So here's what that leaves you with. Information is not a ghost that floats above the physical world. It is part of it, woven into the same thermodynamics that governs heat and engines and the arrow of time. A bit is a physical thing. Erasing it is a physical event with a physical cost. And forgetting, the simple, universal act of destroying information, is the one operation the universe will never let you do for free. Every deletion is a tiny transaction, paid in heat, recorded by the cosmos. Your laptop clearing a cache, a neuron overwriting an old memory, the demon wiping its mind. All of it warms the universe by the smallest, most honest amount. Not because the machines are imperfect, but because information and reality are the same kind of stuff. And the second law is keeping the books. The universe, it turns out, charges a fee to forget, and it never, ever forgets to collect. That's the fine print on information itself, and reading it is exactly what this channel is for.